Chapter 5. Towards Green Energy. What is energy? Energy is an ability to produce change and the capacity to do work. What are the different forms of energy? Kinetic energy, potential energy, light energy, heat energy, and sound energy. Use of energy. In modern civilization, energy has become a primary need, along with food, cloth, and shelter. We use energy in everything that we do. Law of conservation of energy states that energy cannot be created nor be destroyed, but it can be converted to one form from another. In previous standards, we have learnt about energy, sources of energy, and various concepts related to them. Now we will learn about various sources that are now used for the generation of electrical energy, the methods that are used for this, the scientific principles that are used there, the advantages and the disadvantages of these methods, and also what is meant by green energy. Generation of electrical energy. Most of the electrical power plants are based on the principle of electromagnetic induction invented by Michael Faraday. According to this principle, whenever magnetic field around a conductor changes, a potential difference is generated across the conductor. Let us understand this. Take a circular coil and connect two ends of this coil to galvanometer to measure potential difference. This circuit has no source of electricity and the galvanometer initially shows zero reading. The field around a coil can be changed in two ways. Case number 1. If a conductor is stationary and magnet is rotating, the field around the conductor changes. Now take a bar magnet and move it across the coil facing north pole towards the coil. You will observe that there is a deflection in the galvanometer, indicating current is generated in the coil. Now if you move magnet away from the coil, you will again get deflection, but in opposite direction. Case number 2. If a magnet is stationary but the conductor is moving, then also the field around the conductor will change. Now if you keep the bar magnet at rest and move the coil, the galvanometer again shows deflection. Thus, in both cases, a potential difference is created across the conductor. The electrical power generating machine based on this principle is called electric generator. Such large generators are used in commercial power generation plants. Turbine is used to rotate the magnet in the generator. A turbine has blades. When a flow of liquid or gas is directed on the blades of the turbine, it rotates because of the kinetic energy of the flow. This turbine is connected to electric generator. Thus the magnet in electric generator starts rotating and electric energy is produced. This method of electric energy generation can be given as: to generate electricity based on the principle of electromagnetic induction, we need a generator. To rotate the generator, we need a turbine, and to drive the turbine, we need an energy source. Based on which type of energy source is used to rotate the turbine, there are different types of power generating stations. The design of the turbine used in different types of power stations is also different. Thermal energy based electric power station. In this, the turbine is rotated using steam. Water is heated in a boiler using the thermal energy released due to burning of coal. Steam of very high temperature and pressure is generated. The energy in the steam drives the turbine. Thus, the generator connected to the turbine rotates and electrical energy is produced. The steam is converted back into water and the water is recirculated to the boiler. Since thermal energy is used here to generate electrical energy, such power plants are called thermal power plants. In thermal power plants, the conversion of chemical energy in the coal into electrical energy can be given as: chemical energy is converted into thermal energy. Thermal energy is converted into kinetic energy of steam. Kinetic energy of steam is converted into kinetic energy of turbine. And finally, the kinetic energy of the turbine is converted into electrical energy. How thermal power plant works. After combustion of fuel, In this case coal, in the boiler, the emitted gases are released to the atmosphere through very high tower. Once the turbine is rotated using the steam at high temperature and high pressure, steam temperature and pressure decreases. This steam is converted back to water by taking out heat from it, that is, by cooling it. This is done in the condenser using water in the cooling tower. The water in cooling tower is circulated through the condenser. Heat energy in the steam is given to the water and the steam condenses back to water. The heat absorbed by the water is then released to atmosphere through vapor and heated air through cooling tower. Although thermal power generation is a major way of electricity generation today, it suffers from certain problems. Number 1. Air pollution due to burning of coal. Burning of coal results in emission of gases like carbon dioxide, sulfur oxide, and nitrogen oxide, which are harmful to the health. Number 2. Along with the emission of gases due to burning of coal, soot particles are also released into the environment. This may cause serious health problems related to the respiratory system. Number 3. The reserves of fuel used in this method, that is coal, are limited. Therefore, in future, there will be limitations on the availability of the coal. Power plant based on nuclear energy. In the power plant based on nuclear energy also, steam turbine is used to rotate the generator. However, here, the energy released by fission of nuclei of atoms like uranium or plutonium is used to generate the steam of high temperature and high pressure. The energy in the steam rotates the turbine, which in turn drives the generator, producing electricity. Thus, here nuclear energy is converted into thermal energy. Thermal energy is converted into kinetic energy of steam. Kinetic energy of steam is converted into kinetic energy of turbine. And finally, the kinetic energy of the turbine is converted into electrical energy. How does nuclear fission take place? When neutron is bombarded on atom of uranium-235, it absorbs the neutron and converts into its isotope uranium-236. Uranium-236, being extremely unstable, converts into atoms of barium and krypton through a process of fission releasing 3 neutrons and 200 MeV energy. The 3 neutrons generated in this process cause fission of 3 other uranium-235 atoms, releasing more energy. The neutrons released in this reaction release more energy through the fission of more uranium nuclei. This process of fission of uranium-235 atoms continues and is called the chain reaction. In nuclear power plants, a controlled chain reaction results in release of thermal energy, which is used for electric energy generation. A nuclear power plant does not use fossil fuel like coal. Therefore, problems like air pollution do not arise. Also, if sufficient nuclear fuel is available, this can be a good source of electrical energy. However, there are a few problems associated with nuclear power generation. Problems associated with nuclear power plants are: the products after fission of nuclear fuel are also radioactive and emit harmful radiations. The products are called as nuclear waste. How to dispose the nuclear waste safely is a big challenge before the scientists. Power generation plant based on energy of natural gas. In this plant, the turbine is run by a gas at a very high temperature and pressure generated by combustion of natural gas. A flowchart showing various stages in the power generation plant based on natural gas energy can be given as: there are 3 main sections in this type of plant. Pressurized air is introduced into the combustion chamber using a compressor. In the combustion chamber, the natural gas burns in the presence of the air. The gas at very high temperature and pressure generated in this chamber runs the turbine. The turbine then drives the generator to produce electricity. Step-by-step transformation of energy in this plant can be given as: chemical energy of natural gas is converted into kinetic energy due to combustion of natural gas. Kinetic energy produced is now converted into kinetic energy of turbine. And finally, the kinetic energy of the turbine is converted into electrical energy. The efficiency of this type of power generation plant is higher than that of power generation plant based on coal. Moreover, since the natural gas does not contain sulfur, burning of natural gas results in less pollution. Some natural gas-based power plants and their capacities are listed below. Samaralkota in Andhra Pradesh generates capacity of 2620 megawatt of electrical energy. Anjanve in Maharashtra generates capacity of 2220 megawatt of electrical energy. Bhavana in Delhi generates capacity of 1500 megawatt of electrical energy. Kondapalli in Andhra Pradesh generates capacity of 1466 megawatt of electrical energy. Electrical energy generation and environment. When electrical energy is generated using fossil fuels like coal, natural gas, and nuclear fuels like uranium and plutonium, it can lead to environmental degradation. Number 1. Burning of fossil fuels. Burning of fossil fuels like coal and natural gas leads to emission of certain gases and soot particles. Increase in percentage of carbon dioxide in the air due to burning of fuels affects environment severely. This results in air pollution. Nitrogen dioxide generated due to burning of fuels like coal, diesel, and petrol lead to problems like acid rain. The phenomenon of global warming is an example of this. Incomplete combustion of fuels leads to formation of carbon monoxide. It adversely affects our health. Soot particles generated due to incomplete burning of fossil fuel cause air pollution. It can lead to problems related to respiratory system like asthma. Number 2. Fossil fuel, non-renewable resources. It took millions of years of formation of fossil fuels like coal, crude oils, and natural gases, that is, LPG and CNG. Also, the reserves of these fuels are limited. They are going to deplete in the future. It is said that with the current speed of their use, the coal reserves in the world would last for about another 200 years or so, and the natural gas reserves for about 200 to 300 years. Number 3. We have also discussed above about the problems in the use of nuclear energy, like the disposal of nuclear waste and the possibility of disaster due to accident in nuclear power plant. Considering all these points, it can be said that the energy generation from fossil fuels and nuclear fuels are not environment friendly. Hydroelectric energy. The schematic of hydroelectric plant can be given as: water from about middle of the total height of the dam is taken to the turbine. Kinetic energy in flowing water or the potential energy in water reservoir is a conventional source of energy. The potential energy in water stored in dam is converted into kinetic energy of water. The kinetic energy of the flowing water drives the turbine. The turbine in turn drives the generator to generate electricity. Advantages of hydroelectric power generation. Number 1. Since no fuel is burnt in hydroelectric power generation, there is no pollution resulting from combustion of fuels. Number 2. If there is sufficient water storage in the dam, it is possible to generate electricity as and when necessary. Number 3. Although water reservoir is used for power generation, it can be replenished during rainy season, leading to uninterrupted power generation. Major hydroelectric power plants in India are: Tihri in Uttarakhand generates capacity of 2400 megawatt of electrical energy. Koyana in Maharashtra generates capacity of 1960 megawatt of electrical energy. Srisailam in Andhra Pradesh generates capacity of 1670 megawatt of electrical energy. Nathpa Zakri in Himachal Pradesh generates capacity of 1500 megawatt of electrical energy. Electricity generation using wind energy. The kinetic energy in wind has been used since long for lifting of water or for driving floor mill, etc. The wind energy can also be used for electricity generation. The machine which converts the kinetic energy of wind to electrical energy is called wind turbine. As the wind strikes the blades of the turbine, the blades rotate. The axle of the turbine is connected to the electric generator through a gearbox. The function of the gearbox is to increase the rotations per unit time. Thus, the rotating blades drive the turbine, and the turbine in turn drives the generator to generate electricity. The energy conversion process can be given as: the kinetic energy of the wind is converted into kinetic energy in turbine. Kinetic energy in turbine is now converted into electric energy. Wind turbines with capacity right from less than 1 kilowatt to about 7 megawatt or 7000 kilowatt are commercially available. Depending on the wind velocity available at the site of installation, wind turbine with specific capacity is selected. The wind velocity at specific location depends on many geographical factors. Wind velocity is usually high on seashores, and that environment is appropriate for installation of wind turbine. Wind energy is a clean energy source. However, the wind velocity necessary for wind energy generation is not available everywhere. In that sense, use of wind energy is limited. Electric energy generation using solar energy. Using the energy in the sunlight, electric energy can be generated in two ways. Number 1. Electrical energy can be generated directly from solar radiation without using generator and without using the principle of electromagnetic induction. This happens in solar photovoltaic cells. Solar photovoltaic cells convert the solar energy directly into electrical energy. Number 2. In the second method, the energy in solar radiation is converted into thermal energy first. Then, a turbine generator system is driven using that thermal energy to generate electricity. Solar photovoltaic cell. Solar photovoltaic cell converts the solar radiation energy directly into electrical energy. This electrical energy is DC in nature. This is called solar photovoltaic effect. Solar cells are made of special type of material called semiconductor. For example, silicon. A silicon solar cell of dimension 1 cm generates current of about 30 milliampere, potential difference of about 0.5 volt. Thus, a silicon solar cell of dimension 100 cm square will generate current of about 30 milliampere per centimeter square into 100 cm square. That is about 3000 milliampere. So, 3000 milliampere is equal to 3 ampere and potential difference of about 0.5 volt. It is important to note that potential difference generated from solar cell is independent of its area. If two solar cells and are connected in series, let's say two solar cells are C1 and C2. So, potential difference generated by C1 is V1 and potential difference generated by C2 is V2. The potential difference obtained from this combination is addition of the potential differences of individual solar cells, that is V1 plus V2. Current generated by C1 is I1 and current generated by C2 is I2. Current generated by combination of both is C1 plus C2 is I. However, the current generated from this combination is equal to the current from an individual cell, that is, I is equal to I1 is equal to I2. It means that when solar cells are connected in series, currents from individual cells are not added. If two solar cells are connected in parallel, the current generated from this combination is the summation of currents from an individual solar cells. So, I is equal to I1 plus I2. However, The potential difference obtained from this combination is the same as the potential difference obtained from individual cell. V is equal to V1 is equal to V2. Thus, if two solar cells are connected in parallel, the potential differences from the two cells are not added. In this way, by connecting many solar cells in series and in parallel, solar panels generating required current and potential difference are made. For example, if 36 solar cells, each of size 100 cm square, are connected in series in a solar panel, it will give potential difference of 18 volt and current of 3 ampere. Many such panels are connected together to generate electricity on larger scale. A good solar cell can have an efficiency of around 15%. It means that if a solar panel receives power of 100 watt from solar radiation, the electrical power output from the panel will be 15 watt. Many solar panels are connected in series and in parallel to generate required current and potential difference. Many solar cells come together to form a solar panel. Many solar panels connected in series form a solar strings, and many solar strings connected in parallel form a solar array. As we can obtain as much electrical power as needed, they are used in applications which need marginal power to power station of megawatt capacity. The power available from the solar panels is DC. So in applications which need DC power, for example, electric lights based on light-emitting diodes, the energy can be directly used. However, since the energy from solar cell is available only in presence of sunlight, the energy has to be stored in batteries for use at later time. However, most of the equipment in domestic as well as industrial use runs on AC power. In such case, the DC solar power must be converted to AC power using an electronic device called inverter. We have seen that many solar panels can be connected together to generate whatever energy we need. The DC power generated from these panels is first converted into AC power. A transformer transforms the voltage and current levels of the generated power, and then it is fed into the electricity distribution network. The power available from solar cells is DC. So in applications which need DC power, for example, electric lights based on light-emitting diodes, the energy can be directly used. However, since the energy from solar cells is available only in presence of sunlight, the energy has to be stored in batteries for use at later time. In this way, electricity is generated without any fuel combustion and so without any air pollution. However, since the energy is generated using solar radiation, solar cells can generate electricity during daytime only. Solar thermal power plant. We have seen that thermal energy generated from coal and nuclear fuel can be used to generate electricity. Thermal energy can also be generated from solar radiation and can be used for electricity production. Reflectors reflect and concentrate solar radiation on absorbers. There, solar energy is converted into heat energy. Using this heat energy, steam is generated to drive the turbine and the generator.